27, 12. Minimum cost to make all characters equal. We are giving a zero index binary string s of less n, of which you can apply two types of operations. So the first operation is that we're gonna choose an index I. So for example, from here, we're gonna choose this. Maybe from here we're gonna choose this index I. So the index is 1. We're gonna choose this index I and invert all characters from 0 to index. So what is the invert? We just need to turn the zeros to 1. So we're gonna turn those two zeros to 1, and with a cost of 2. So for example, so after that it's gonna always be 1. So this is the final answer. It's gonna be 2. Or we can choose an index I and invert all characters from index I to n minus 1. So for example, 0, 0, 1, 1. We can choose this index I and I to n minus 1, both inclusive, with a cost of n minus 1. N is 4. 4 minus 2, it is also 2. So 2 is the minimum. We just need to return the minimum cost to make all characters of the string equal. So invert just means we're gonna turn 0 to 1 or 1 to 0. So the length of the string is gonna be 10 to the power 5. This means, maybe we can solve it in O(n) time, definitely. Maybe n log n time. But for this problem, it is a string. Definitely it is not n log n. We don't need to sort it. Definitely it's gonna be O(n) time. Yeah, if we are solving such problem, normally 0, 1, 0, 1, and 0, 1. So where are we gonna start? Are we going to start from randomly? Maybe from here or there, or we start from the left side, or we start from the right side. Yeah. So what's gonna be the greedy solution? So instead we solve it from the middle, because from the middle it's going to be really difficult to control. Yeah. So if we start from the left on the right side, and then we just use the greedy idea to check. So for example, if two characters are not equal, for example 0, 1, now we're going to have a decision. We can turn this 0 to 1, or we can turn this 1 to 0. And we can ignore all others, because for others it doesn't matter. Because definitely if we make a revert, we will not change the state of two neighboring integers. So for example, this is a 0, 1. If we turn this 1 to 0, so this is a 0, this is 1, 0. So the state is going to be the same. So those two neighbors are not equal. 0 to 1 not equal, 1 to 0 not equal, 1 to 0 not equal. It is the same, you know. So, but after this one, after we solved this one, 0, 0, we're going to check the next one. If we want to turn all those ones to be 0 or to be 1, it doesn't matter. Now, we're going to check this 0 and 1. It is not equal. Now we're going to have a decision. Maybe we're going to turn the left side always 0 to 1, or from the right side 1 to 0. Maybe we're going to choose 1 to 0. Let's just check. Now, this 1 to 0, this is 1, 0, 1, right? Now we're going to continue to check. If they are not equal, maybe we're going to turn right. Yeah, we're going to turn this 1 to 0, 1, 0. But this is not the optimal solution, and this is not the greedy idea. So the greedy idea is that we can turn the left side part, we can turn the left part, or we can turn the right part, because the cost gonna be determined which one is minimum. So if I is I minus plus 1 minimum, or n minus I minimum. So if from the left side is the minimum, we're gonna invert the left side. If the right side is the minimum, we're gonna invert the right side. Yeah. Now let's just continue to use this idea to solve the problem. So we're gonna have 0, 1, 0, 1, and 0, 1. So n gonna be 6. It is the length of the string. So from the beginning, this is I, and this is a 0 index, and this is the index 1. Yeah. So from index 0 to index 1. Now we're gonna check those two characters, 0, 1. They are not equal. Now we can have two decisions. We can turn this 0 to 1, or we can turn this 1 to 0. But which one we're gonna choose? So from the left side, if we turn this 0 to 1, so the cost is gonna be I plus 1. I is 0. Yeah, I think it's gonna be so the cost gonna be I plus 1. So I gonna be 0 here. So 0 plus 1, so the cost gonna be 1. So what about the right side? If we turn this 1 to 0, so the cost gonna be n minus I. here this I is 1, so 6 minus 1, it is 5. So definitely we're gonna choose 1 because 1 is minimum. Yeah, so this means for this operation, we're gonna invert 0 to 1. So this is gonna be 1, and this one gonna be 0, and we have a cost of 1 currently. And then we just invert all others. This is 1, 0, 1, 0. Yeah. Now, this one is finished because we finished our inversion. Yeah, definitely we don't need to invert it back because that is not so great idea. Now we're gonna move to the next step. So this is 0, 1. Now we still have two decisions. We're gonna invert 0 to 1 or 1 to 0. Which one is smaller? Because this one is smaller because I plus 1, it is 2. But n minus I, n minus this I, n minus 2, it is 4. So definitely we're gonna no, let me just think more about it. Yeah, so the first step is that we're gonna invert this 0 to 1. Yeah, we're gonna invert this 0 to 1 because they are not equal. Yeah, let me just think about it. As this is 0 and this is 1. The cost from the left side is 1, so this means we're gonna invert. Yeah, now we're gonna check the next. Yeah, for the next one, this means we're gonna invert 0 to 1. So this is 1. And this is 0. Yeah. Oh, I'm confused. Let me just try to check why it didn't work. I'm gonna so I have 0, 1, 0, 1, and 0, 1. First of all, I'm gonna check the neighbors of 0 and 1 if they are not equal. I'm gonna check which one. So here I gonna be 1. I'm gonna check Si and Si minus 1. So if they are not equal, so I'm gonna invert this 0 to 1. Yeah, so 0 gonna become 1, and this is 1, and this is 0, and this is 1, and this is 0, and this is 1. Yeah, now I'm gonna continue to check. Yeah, I'm gonna check this 1 and this 0. So what's gonna happen is currently this one equals to this one. Definitely if I invert from the left side, it should always be valid. I mean, there are two ones that can become two zeros, so it doesn't matter because it is always the same character. Now I'm going to check this one, 0, 1 and 0. Which one is smaller? Definitely from the left side it is smaller. So this means I'm going to invert from the left side. Yeah. So first step, I have a cost of 1, and then what's going to be the minimum cost? I'm going to have a minimum cost of 2 because I want to invert this 1 to 0. So this means from the left side it's going to always be 0. It's going to be something like this, and I have cost of 2. And then I'm going to continue to check. So this is 0 and 1. Definitely from the left side it is always equal. Yeah. So this is the greedy idea because I don't need to go back. Now this is a 0, 1. Here is a 0, 1. So which one is smaller? So from the right side, this is index 3. So 6 minus 3. it is 3. From the left side, it is I plus 1. I plus 1, I2 plus 1, 3. So yeah, they are equal. So this means I can invert the left or I can invert the right. It doesn't matter. So what about I just invert the left? It's going to be 1, 1, 1 here. Yeah. So I have a cost of 3, and I'm going to continue. So this is a 0, 1. Now I found those one, they are not equal. This is 1, 0. So I want to invert the right side because right side is smaller. So n minus I. So this is n6 minus 4. It's going to be 2. So after invert, this is 0 going to become 1, and this 1 going to become 0. Now for the last step, yeah. So the last step is 0, and I going to be 5. 6 minus 5, it is smaller, it is 1. So I need to plus a 1. So after that, this 0 going to become 1, and after all those characters are going to become 1. Yeah. For our examples, it is 1, but if it is a 0, maybe it is also possible. Now we're going to sum up together. So this is 1 plus 2, 3 plus 3, 6 plus 2, 8 plus 1, 9. So this is our final answer. So the greedy idea is just like that. We're going to check from the left to the right. If they are not equal, we're going to choose the minimum. Now let's just prepare the final result. So the result gonna from 0 gonna equal to 0, and n gonna be length of the string. Now I'm gonna check one by one. So for I in range 1 to n, if si minus 1 and not equal to si, so this means those two neighboring characters are not equal. Definitely I need to do something, but I need to choose the minimum one. So I'm going to plus equal to the minimum one. So from the left side, so according to my example, so for example 0, 1 and 0, 1, yeah, so this is my I. I'm going to starting from 1. So from the left side, so here is I minus 1. If I choose from the left side, it means it is I minus 1. This is the index, but for our calculation, we need to use I minus 1 plus 1. Yeah, because from here, we need to use I plus 1. This means I minus 1 plus 1. So it's going to become I from the left side. From the right side, I use I, so it's going to be n minus I. So finally, I just need to return the result. As you can see, the coding is going to be really easy, but it's really difficult to think about it because it is the greedy idea. We have to think about it why we're going to use this idea, and the time complexity is O(n). Yeah. So the idea is that we can always check the two neighboring numbers. If they're not equal, definitely we can do something. We can invert the left side, or we can invert the right side, but we have to do an inversion each time. Otherwise, how can we make it equal? Yeah, we can do it from the middle, right, or left side. It doesn't matter. But from the left side, maybe it's the easiest way to solve it. Now, if they are not equal, we're gonna have to make a decision. We're gonna make a decision to do something, and the decision is by greedy idea. We're gonna choose the minimum cost. Now it becomes 1, 1, and we check those two neighbors, and we have to continue to make the decision. We're going to invert the left side or the right side. So definitely, all the neighbors are independent to each other. I mean, this 0, 1 not equal. So after inversion, the becomes 1, 0. They are also not equal. So we have to do something. So from here, this is 0, 1 not equal. We have to make an inversion, and this 1, 0 not equal. And from this 0, 1 not equal, we have to continue to do that. But we can choose to invert the left or right. After inversion, definitely all those numbers are going to become equal. So this is the basic idea. I think that's all about it. Thanks for watching. See you next time.